All right. Welcome, everyone. Our next talk is by David Lee on fast universal data access with Apache Arrow ADBC. Over to you, David. Can we all welcome David with a round of applause, please?
Thank you, everyone. Can you hear me? Is this working? Cool. So thanks. Today, I'd like to introduce a project that I've been working on for the past few years, which is called Apache Arrow ADBC. And so I'd like to introduce, kind of what it is, how it works, and show you some ways that it might be useful to you if you're doing data analytics, data science, or something along those lines. So let's jump right into it. First of all, let's talk about what ADBC actually is. So ADBC stands for Arrow Database Connectivity. And as you might have guessed from the name, ADBC is very much something like JDBC or ODBC. So I actually wonder, how many of you have worked with JDBC or ODBC before? How many of you actually like the experience? Thought so, right? Those APIs are kind of painful to use. ADBC is a standard like those APIs, but the goal for ADBC is to be made for people like us. It's made for doing data analytics. And what I mean by that is that it aims to be faster, easier to use, and entirely open source. Okay, so those are some big claims, so I like to back those up with some actual numbers and examples. First of all, when I say faster, what do I mean by that? Well, what I mean is that ADBC is 3 times faster. We can look at a quick example here, right? So it turns out that Pandas already supports ADBC, and so we can use it for a quick demo. Here we're going to read 16 million rows from a Postgres table into a Pandas data frame. And we're going to time how long that takes with both SQL Alchemy and with ADBC. With SQL Alchemy on the left, it takes about 24 seconds. And with ADBC, the same operation takes only 8 seconds. So, it's already 3 times faster. And as we'll see, this isn't even this isn't even the best use case or the best case scenario for ADBC. When I say easier, what I mean is that ADBC is just a normal set of Python packages. You don't have to go hunting for the ODBC driver manager and figure out where to install the libraries. You don't have to deal with the JVM and Py4j and all those things. You can just pip install the libraries and use them. Or you can install from Forge if that's more your thing. You can use Pixie or whatever package manager you like. And of course, as I just mentioned, support for ADBC is already available in libraries like Pandas or Polars. And of course, those are fairly popular libraries. So you probably already have access to ADBC even without knowing it. If you're not using one of those libraries, you can still use the native Python APIs. All of the ADBC libraries implement DB API 2.0, which is the standard Python database interface. So that's kind of like a high-level overview of what ADBC can do, but let's dig more into that, right? So let's talk about what exactly the project is like. So again, I said ADBC is an API standard, just like JDBC and ODBC. What that means is basically ADBC defines a bunch of APIs or interfaces for your code to use and for us, driver developers to implement. So it's one set of APIs that works whether you're using, no matter what database you're using. So again, it's also just like DB API in Python. That's the whole idea. Where it's different, as I've mentioned, is that ADBC is for analytic applications. It's for doing data science. It's for doing data analytics. If you're working in machine learning or AI, ADBC is meant for you. And specifically, what I mean by this is that the ADBC APIs and implementations are designed around and optimized for bulk data, for batch data, right? So again, if you think about DB API, JDBC, or ODBC, how do those APIs work? They're all based around, iterating through one row at a time. And if you have, 100 million rows to iterate through, that's kind of a waste of time. The goal behind the ADBC APIs is to be entirely batch-oriented, to give you a data frame from the start so that you're not, wasting time iterating through rows one at a time, and you're not wasting time converting data. Of course, all of these APIs are for database access. That's just as true for ADBC. You can see, I showed Postgres earlier. SQLite also works, but of course, ADBC also supports things like BigQuery or Snowflake, more modern cloud-hosted data warehouse kind of projects. It also supports kind of the new fancy things like DuckDB. So there's a broad variety of databases and data warehouses that are supported. But it's this last point that I think deserves a little more attention. So ADBC is based around a project called Apache Arrow. And it turns out I'm also one of the maintainers of Apache Arrow. I'm kind of curious if anybody here has actually heard of or used Arrow before. So a few people, but it's not super widely known. So let's talk about what Arrow is, because I think Arrow is also important to us for people who are doing data analytics, data science, and those kinds of things. So again, what is Arrow even? Well, Arrow describes itself as an open source, language-independent columnar memory format. That's a lot of fancy words. So again, I want to take this and kind of break it down and explain what that all means. First of all, I want to talk about what columnar and row-oriented mean. If we have a data frame or a data table in memory, what does that actually look like? A data frame is kind of a two-dimensional object, but the memory of our computers, is a one-dimensional kind of thing. So we have to do something to our data frame to actually represent it in memory. And of course, there are kind of two obvious ways you can do this, right? You can either slice the table into rows and make each row its own object, and we call that row-oriented data. Or you can slice the table into columns, make each column its own object, and then we call that columnar data. So honestly, row-oriented data is probably more natural to most of us. I think it's pretty natural to say I have a list of tuples, I have a list of dictionaries, I have a CSV file. Those are all row-oriented. It kind of matches how we think, right? A row of data represents one conceptual object. It represents a person in a database, something like that. But I said Arrow is columnar. So why would we choose to slice data in this kind of unnatural way? But before I get to the why, I also want to talk about what memory format actually means. So this is kind of something that we don't really think about as Python users necessarily, but of course, in memory, everything boils down to a bunch of bits and bytes, and we have to figure out what exactly those bits and bytes are. So when I say memory format, what I mean is that Arrow is actually a specification for how to lay out arrays of data in memory. If you have an array of 32-bit integers, then Arrow says, each of those 32-bit integers has a certain endianness, should be aligned, should not have any padding in between them, nulls should be represented by a separate array, all of these little things that we don't really think about as Python users. And the reasoning behind that is twofold, as we'll see. One is it helps contribute to just better performance. If we compare this against a naive Python representation, like a list of tuples, well, the list of tuples, the list is going to point to a tuple object. The tuple object is going to point to an integer object. All of those pointers, means extra overhead in memory, extra overhead for accessing the values. And Arrow's trying to avoid that. The second reason, as we'll see more about later, is that by standardizing all of these details, we can more easily share this data between different systems. Okay, but again, we don't really think about this in Python. What's the benefit to us as Python users? First of all is probably you're already using columnar data without realizing it. Columnar data is or has become fairly popular over the past few years across different projects in databases, in machine learning, and in data science. And the general reason is that it makes everything more efficient. It makes everything faster. And, faster means it saves us time, it saves us money, and that's pretty important. So there's some reasons here, but instead of talking about it in abstract, let's look at things in a slightly more concrete example. So if we want to calculate the mean or the average of a price column, let's think about what happens with row-oriented or columnar data. First of all, let's say we're just trying to load the column from disk, right? So we have a data set, it might have 1,000 columns, maybe some of you have dealt with more than that, 10,000 columns, who knows how far it goes. And you want to just load one column from that data set. Well, if you have your data in row-oriented format, what happens? Each of your rows is stored together on disk. So if you only care about one column, you still have to iterate through every single row to pluck out the one value you care about. And so you're basically doing a bunch of extra wasted work, or you're seeking all over the disk. That's not going to be as efficient. With columnar data, the key thing to remember is that columnar data stores values of the same column and the same type right next to each other. And so when we want to load our one column from disk, we can seek directly to the column, load just that column, and not have to do any extra I/O. So just loading the data is faster with columnar. Of course, that's not an advantage if you're working with every single column, but for the kinds of use cases that I've been talking about, that's probably not what you're doing most of the time. Probably you only care about a few of the columns. Even when the data is in memory, again, let's think about row-oriented versus columnar formats. If your data is in row-oriented format and you load, say, the first price value from memory to do the computation, your CPU is going to see that you've touched this value in memory. It's going to want to prefetch the data next to it because it's very likely you're about to work with it. But that's, again, it's not true when you have row-oriented data. You loaded the first value in the row, for instance, but you probably didn't care about the rest of the row. But the rest of the row is now sitting in your CPU cache, taking up space, even though you're not using it. With columnar data, again, you touch the first value in the column, the CPU prefetches all of the data next to it. The data next to it happens to be the rest of the values you care about, and your computation goes faster. Now, some of you who have worked with hardware might say that's not exactly true. Modern CPUs are a little smarter than this. It can do a little more than this. But in general, that's the principle. Columnar data works better with the way our hardware works, whether that's CPU or whether that's your new fancy NVIDIA GPU or your FPGA or things like that. Again, these are things that we don't really think about as Python developers probably, but it does influence the design and implementation of many of the libraries we use. And so actually, if you use pandas, if you use NumPy, if you use Parquet, any of those tools are already based around columnar data. So you might say, wait a second. I've been talking this whole time about how Arrow is cool because it's columnar, but then I said that all of these tools are already columnar. So what's the point of having Arrow? Why am I spending so much time talking about it? Well, I'd like to basically show you that probably you're already using Arrow, even though you might not know it. So we actually built this website to help you understand whether you might be using Arrow in your tools already. And the website is designed to walk you through things and tell you yes or no. And of course, you can see the QR code, but the website is arrowinmydatastack.com. And of course, you might have seen the answer is yes. You already use Arrow. If you use pandas or polars, two very popular libraries, those are actually built around Arrow already. If you use Hugging Face datasets, that's built around Arrow. If you use DBT Fusion, they just announced a huge rewrite of DBT, right? That's actually based around Arrow already. So the thing about Arrow is that it's something that kind of is already in your ecosystem, even if you might not have realized it. And it's not just those, Python adjacent projects that use Arrow. It's the whole ecosystem. If you're using Google's BigQuery, one of the ways you can fetch the results of your query is in Arrow format. If you're using Databricks or Snowflake, that's the same. If you use PySpark and you write a UDF, How does Spark give the data to your UDF? It's actually in Arrow format. All of these tools are already based on Arrow. And so I said earlier that the value of Arrow isn't just that it's faster, but that it's a standard that everyone uses. And that's the key point I think is good to understand. Because Arrow is standardized down to the last bit, it makes it possible for all of these projects to interoperate without extra overhead and without extra development effort. You can have, a system with Spark and DuckDB and Snowflake and Parquet and Polars all working together and sharing data without having to convert it because they're all compatible with this common format. With this common format, we don't have to copy and convert data every time we want to use a different system, right? When you go from PySpark, Spark written in Java and Scala to Pandas written in Python and C, you don't have to convert the data because it's already in Arrow format. And again, because Arrow specifies everything in such detail, not only do you not have to convert the data, you can just pass pointers to the data around, which means you can do zero copy sharing of data between different systems. So I think given this background, it's pretty clear what ADBC is supposed to be, what the purpose of ADBC is supposed to be. ADBC is just a bridge between, this whole ecosystem of Arrow-enabled tools and this whole system of different databases. Again, it's supposed to be the standard API for these data science use cases. Not to belabor the point too much, but again, let's think about what happens without, an Arrow-enabled interface when we're trying to use these new databases, data warehouses, and other systems, right? So I just mentioned if you get data from Snowflake, it comes in Arrow format. And if we're trying to use it with a standard Python driver, say one that implements DB API, well, DB API is based around Python objects, right? And it's row-oriented. So that means the driver has to take that Arrow data off the wire, has to deserialize it and convert it into a bunch of Python objects. And of course, you don't want to work with the Python objects directly. You want to use pandas, you want to use polars, something like that. So you have to convert the data back into Arrow format just to use it. And so that's kind of pointless, right? We're doing all this conversion work for nothing. With ADBC, because ADBC's interfaces are based around Arrow data, we can just take that Arrow data from Snowflake, plug it directly into pandas. Arrow makes sure that both sides are compatible. You don't have to copy the data. And we can get started. We can, start doing actual work much more quickly, much more efficiently. So again, this is what I mean when I say ADBC is built for analytics. It's trying to avoid these inefficiencies in the existing APIs. So again, ADBC is a standard API. Your application only has to work with that API. Your application only needs to support Arrow data. As long as you have Arrow data, you can plug it into whatever tool you want to use, whether that's Pandas, Polars, Parquet, or something else. And of course, I mentioned, a bunch of these vendors support Arrow data already. But what about the vendors that don't support Arrow data? I showed, Postgres and I mentioned SQLite. So yes, those vendors, the driver for Postgres does have to convert the data into Arrow format. So it's not as efficient as it could be just because Postgres itself doesn't support Arrow data. But you don't have to worry about this, right? Again, since you only have to worry about the ADBC API and the Arrow data format, you don't have to worry about whether the driver in the backend is doing data conversion or something. So again, that comes back to the idea of Arrow being this universal data format and ADBC being this universal data access API. There's one more benefit that comes from Arrow and ADBC being language independent. So it means that we as Python users benefit from a bunch of development effort that goes on in other language communities as well, including, C++, Go, and Rust. So actually that Postgres driver I just mentioned is actually written in C++, is written by C++ developers for, C++ use cases. But because it's all the same API and the same data format, we can really easily repackage it as a Python wheel for us Python users to use. And C++ developers being C++ developers, they spent a lot of time optimizing the driver and doing fancy things like using the Postgres copy command, using the Postgres binary format and things like that, which are kind of annoying to deal with, but which make the driver a lot faster. And so that's why even though, I mentioned Postgres isn't Arrow native, we were still able to show a 3x speed up on that second slide because these C++ developers have put in so much effort into making things faster. And of course, that's true for Go and Rust as well. We have drivers for things like Snowflake, and those are written in Go. So yeah, again, Python users can benefit. We as Python users benefit from all of these different developers. So I want to just finish up with, a couple more examples. So I've already shown how you can take a table or a query in SQL and just read it into a pandas or polars data frame. But you can also go the opposite way. And again, you can see how these APIs are already built into these libraries. So even though you might not know it, you could already use ADBC without being aware of it. And actually, so again, you can take data that you already have in a data frame and dump it into a database table in one line of code. And just judging from the number of feature requests and bug reports that I get about this, that actually turns out to be one of the most popular features. If you're doing like ETL, you want to read a bunch of data, do something to it, write it back. Well, this makes it a lot easier and it makes it a lot faster. Again, the performance-obsessed developers in Go and C++ and so on have put a bunch of work into making this fast for us. So if you're using Snowflake, what happens is the Snowflake driver will take your pandas data frame, write a Parquet file to Snowflake, and then copy the Parquet file into the Snowflake table for you, which is going to be faster than just trying to run a bunch of inserts. And of course, you can do a few other things like list all the available tables in a database and things like that. So just a few extensions that are useful, but not part of the base DB API APIs. And so finally, again, I've thrown a bunch of information at you. So there's some resources if you want to learn more about things. There's a tutorial in the ADBC documentation. I put up these slides in a GitHub repo along with a little bit of demo code, but also the documentation has a bunch of code samples for working with different databases in Python. And again, all of this is open source. So if you want to learn more, if you want to contribute, if you want to file a bug report, if you have a feature request, you can find it all on GitHub. You can also join the mailing list and ask questions as well. So I hope this has been interesting to everyone. Thank you all for listening, and I'm happy to take any questions.
Yeah. Any questions? Questions?
Thank you very much for your talk. I just have one question. What would be for the next release? Are there any challenges that you are working on with the library, or what are some important issues that one can contribute right now?
Yeah, there's basically always more work that would be appreciated on just adding new features, fixing bugs, maybe even contributing new drivers. For instance, the Databricks people have been working on a new driver for ADBC in a repository. There's little things like there's some features that one driver or another might not support. Feel free to reach out. I can always point you to some issues that I think might be easier for a beginner or a newcomer. Of course, again, everything's open source, so there's a long list. There's a long backlog to look at as well.
I just checked, and indeed there is a lot.
Yeah.
Okay, thank you.
I'd just like to say thank you very much for your talk. It's very interesting, and also for the work that you've done with Arrow, because it's a really pleasure to be able to use libraries like this within Python. I guess my question is around using polars, this idea of having lazy frames. How far back can you extend that idea of laziness back towards a database? So are you able to bring in the data lazily as well using these drivers?
Yeah, so it's essentially up to the driver implementation, but they will generally stream data. Now, of course, a lot of them are probably going to buffer at least some data internally. But yeah, if in general, the core Arrow abstraction that's being used is called an Arrow array stream, which is essentially an iterator of batches of data. And so if you aren't pulling from the iterator, that should generally be translated into back pressure. That said, of course, things could always be improved. So we are actually working on a explicitly asynchronous interface for this sort of thing, and that interface will also have explicit back pressure as well.
Okay, thank you very much.
Any other questions?
So I don't know how this could possibly be answered, but I'll ask it anyway. Like you mentioned, like ADBC is sort of a successor to JDBC and ODBC. Both those sort of standards historically have trouble taking. Like JDBC is like more oriented in Java, and nobody really wants to use it outside of Java, and ODBC just never took off anywhere. Like, how do you foresee ADBC to be like accepted into the standard for everything?
Yeah, that's actually a good question to ask, because that is one of the things we're trying to overcome. So one is that we've designed to be, again, language agnostic from the start. So that's why I mentioned all these drivers are built in different languages and can be used from Python. And it can be used from other languages like R or Elixir or Go or Java as well. The other thing is that we're trying to get vendors on board. So the Snowflake driver was developed with the cooperation of Snowflake themselves. Databricks is being developed, again, with the cooperation of Databricks. And we're also trying to get other users on board as well. So, DuckDB is also on board with the API. Microsoft has actually adopted ADBC in Power BI, and they're also one of the biggest contributors to the project. So for instance, if you look at the Power BI docs, there's a little note saying that the Snowflake support in Power BI is built on top of ADBC. And so we're generally trying to expand all this. We're trying to get more vendors on board, more partners on board, and try to make sure that this is a project that's built for the community and not just something being pushed down our throats by just Microsoft like with ODBC or just Sun Oracle like with JDBC.
Any other questions? I have one question from us. So how does ADBC handles large data sets and avoid unnecessary serialization or deserialization?
How does ADBC handle large data sets and unnecessary serialization? Yeah. So again, the large data sets is handled by being a streaming interface at its core. So you have an iterator of batches of data, and you can stream through the data as needed. You can't do things like stream backwards or things like that. Those aren't use cases we're trying to handle. But that's how we handle things that are larger than memory. For, again, serialization, deserialization, the point is that we can avoid doing that in the first place because all these different tools are compatible with Arrow. And so there is essentially no serialization by definition because all these tools support the same data format in the first place.
Makes sense. Thanks. Any other questions? Yeah, all right. Thanks again for a wonderful talk, David.
Thank you.
Again, can you all give a big round of applause to David again for the wonderful